Yes. So everyone, welcome back to the another session. Okay. So we can move to the first question. So the question is that you can see integral of minus 3 to 3 cot inverse x dx. Okay. And also you can see there are 4 options. Okay. So let me write the question first. Yes. So the lower limit is minus 3 and upper limit is 3. And we need to find the value cot inverse, yes, cot inverse x dx. Okay. So we need to find this value. So for this one, just look at here. Cot inverse, yes, cot inverse x dx. So here we can use integration by parts. Yes. Integration integration by parts. So that means we know that integral of u v dx is equal to, yes, integral of u v dx is equal to u into integral of v dx. Yes, v dx minus integral of derivative of u. That means u dash into integral v dx. Yes, integral v dx into dx. Into dx. Into dx. Yes, into dx. Okay, so hereafter, just look at here. Cot inverse x dx. So that means we can consider cot inverse x as u. Okay, and we can write this one. Cot inverse x ds as, we can write this as integral of minus 3 to 3. Okay, cot inverse, I'm going to write it as cot inverse x into 1 dx. X into 1 dx. Okay, x into 1 dx. So hereafter we can consider this one as u and this one as v. So hereafter, after this, just apply integration by parts. Okay, so by using integration by parts, okay, so this is u. So what is that? Integral of u v dx is equal to u into integral of v dx minus integral of derivative of u into integral of v dx dx. Okay, so hereafter, first one, that is, we can write cot inverse x and integral of v dx. V dx means, here we know that v is equal to 1. So 1 dx, integral of dx means x. So we can write as cot inverse x into x. Cot inverse x into x. So hereafter just substitute the limit. So upper limit is minus 3 and the lower, yes, sorry, upper limit is 3 and the lower limit is minus 3. Plus, so the next one is here, look at here. So the next one is minus of integral of u dash, minus of first one of derivative of u dash. We know that here u is equal to cot inverse x. Okay, so u is equal to cot inverse x. So derivative of cot inverse x, d by dx of cot inverse x is, the value is minus. So here first we can write the integral and u dash means, yes, we know that u is equal to cot inverse x. So derivative of d by dx of cot inverse x is equal to minus 1 by 1 plus x square. Okay, yes, minus 1 by 1 plus x square into, yes, what is here? V dx. We know that v is equal to, what is v? The value of v is equal to 1. So v dx means integral dx. So we can write it as x. Okay. So here are, yes, I forgot to mention the limits. So minus 3, 3, minus 3 to 3. So in the next step, we can substitute the limits here. So the lower limit is minus 3 and upper limit is 3. So that means cot inverse x dx. So here we are going to substitute the limits for the x, the variable x. So that means upper limit minus lower limit. So that is 3 into cot inverse 3 into cot inverse 3 minus upper limit minus lower limit. What is the value of lower limit? Lower limit is x is equal to minus 3. So just substitute here. So minus 3. Okay, so minus 3 into cot inverse. What is the value of x? While we are applying the lower limit, the value of x is equal to minus 3. So it is minus 3 plus here. Here for this one, just x into minus 1 by, yes, x into minus 1 by 1 plus x square. So that is integral of minus 3 to 3. We can write it as x divided by 1 plus, yes, 1 plus x square dx. 1 plus x square dx. Okay, so now look at here. Minus 3, yes, here it is minus of minus 3. That means plus 3. It will become positive. So in the next step, we can write 3 cot inverse. Yes, 3 cot inverse 3. Yes, minus. So it will become plus 3 into cot inverse minus 3. So cot inverse minus 3. We know that cot is negative. The value of cot is negative in which quadrant? In second quadrant, the cot is negative. So here cot inverse minus 3, for this one I am going to write it as pi minus. Yes, pi minus cot inverse minus 3. Yes, plus this one, that is integral of minus 3 to 3 x divided by 1 plus x square dx. Okay, yes. So for that one, yes. So hereafter this one, we can consider 1 plus x square. We can consider 1 plus x square is equal to, we can consider this one as t. Okay, so yes, so let me write here 1 plus x square. We are going to consider 1 plus x square is equal to t. So what is the derivative? So the derivative is 2x dx is equal to dt. Okay, let me put it in a box. So after that, here it is minus 3 to 3. 1 plus t square. Okay, so that is, yes, x dx. So in order to, yes, balance this x dx, so there is a 2 here. So we can write 1 by 2 here. Yes, 1 by 2 into minus 3 to 3. Yes. So that is plus 1 by 2 into, yes, we know that 1 plus x square is equal to t. We already mentioned here. So 2x dx is equal to dt. So after applying integration, that is here we know that 2x dx is equal to dt. So that means integral of dt divided by 1 plus t square. So that is integral dt divided by 1 plus t square. We can write it as log. So that is log of 1 plus t square. T square means, yes, log t. We already mentioned 1 plus x square is equal to t. So that means integral of dt by t. Integral of dt by t. So that is, yes, integral of dt by t. We know that 1 plus x square is equal to t. So hereafter we can write, yes, 1 plus x square. 1 by 2 into log 1 plus x square, and after that we can apply the limit here. We can apply the limit. So that is minus 3 to 3. Minus 3 to 3. Okay? Yes. Minus 3 to 3. So in the next step, in the next one, that is we are going to rewrite this once again. This. So that is 3 into cot inverse, yes, cot inverse 3 plus 3 into, just multiply here. 3 into pi means 3 pi. So 3 pi minus 3 into cot inverse minus 3. So that is 3 into cot inverse, yes, cot inverse minus, so it will become cot inverse 3. Okay, so that is 3 into cot inverse 3. Yes, it is positive here. Yes, mistake. Pi minus cot inverse 3. So minus 3 into cot inverse 3 plus 1 by 2. 1 by 2 into log 1 plus x square. So hereafter just apply the limit. So the lower limit is minus 3 and upper limit is plus 3. So while we are applying the upper limit 3 here, so that is log of 1 plus 3 square. So we know that 3 square is equal to 9. So 1 plus 9. So that means log 1 plus 9 means that is 10. So here it will become log mod 10. So let me write log mod 10. Log, yes, 10. So while we are applying the upper limit as 3, we got log 10. And if you are going to apply the lower limit minus 3, again minus 3 the whole square, same, that is 9. So 1 plus 9, that is 10. So hereafter we can write log 10 minus log 10 here. Yes, a single step. This is a single, yes. Log 10 minus log 10. Okay, yes. So in the next step, log 10 minus log 10, the value is, we know that this is 0. And here, just look at here, minus 3 cot inverse 3, and here it is positive 3 cot inverse 3. So we can cancel this, and the remaining is 3 pi. So remaining is 3 pi. Okay, so for this question, the question is that integral of minus 3 to 3 cot inverse x dx. For this one, the correct answer is option C, that is 3 pi is the correct answer. Yes, so we can move to the next one. Yes, so the second question is that integral of 1 by, yes, 1 by root x plus x root x dx. We need to find the value. Okay, so the question is integral of 1 by root of x plus, yes, root of x plus x root x dx. So this is a question. Okay, so first of all we can write I is equal to integral of 1 by root x plus x root x. So hereafter I am going to take root x. Yes, just look at here. Here root x is common here, so we can take it outside. So that means integral of 1 by, yes, 1 by root x, yes, integral of 1 by root x into, yes, if you are just taking root x outside, it will become 1 by root x plus, yes, so the remaining is x. So I am going to write x as root x the whole square, root x the whole square, because root x the whole square, the value is x. So here we can substitute root x into 1 plus root x the whole square. Yes, so that is integral of 1 divided by root x into 1 plus root x the whole square into dx. Okay, so hereafter I am going to substitute for root x, I am going to substitute root x equal to t. I am going to substitute root x equal to t, and the derivative is, we know that d by dx of root x is equal to d by dx of root x, 1 by 2 root x. So after rearranging we can write 1 by root x dx is equal to 2 dt. Okay, after rearranging we can write 1 by, yes, 1 by root x dx is equal to 2 dt, because we know that d by dx of root x is equal to 1 by 2 root x, yes, 1 by 2 root x. So after rearranging we can write 1 by root x dx is equal to 1 by root x dx equal to 2 dt. Yes, so in the next step here we can substitute, just look at here. So in the next step we can write I is equal to, that means here I is equal to, for the next one, yes, I is equal to integral of 2 dt divided by, yes, integral of 2 dt divided by root x the whole square means 1 plus root x the whole square means 1 plus t square. Okay, so I is equal to integral of, yes, integral of 2 dt divided by 1 plus t square. So that is in the next step. In the next step, here we can take 2 outside because it's a constant, and integral dt divided by 1 plus integral dt divided by 1 plus t square. So that is, here we can take 2 outside because 2 is a constant, and the next is integral of dt divided by 1 plus t square. So integral dt divided by 1 plus t square, that is tan inverse t. So that means in the next step we can, yes, I just forget to mention c here. Yes, so that is dt divided by 1 plus t square, that is tan inverse t plus c. Yes, plus c. So hereafter, on the previous step we already noted x is equal to, yes, already noted root x is equal to t. Yes, we already noted here. So just substitute the value of t here. So that is 2 into tan inverse t. So here instead of t we can substitute root x plus c. So this is the final answer. So the final answer is 2 tan inverse root x plus c is the final answer. So from the given question, option B is the correct answer. Okay, yes, so now we can move to the third question. Third one. So the third question is given that integral of 2x minus, yes, the numerator is 2x minus 1 divided by x minus 1 into x plus 2 into x minus 3 dx. So that is equal to, the right hand side is a log mod x minus 1 plus b log mod x plus 2 plus c log mod x minus 3 plus k. The question is that then a, b, c are respectively, we need to find the value of a, b, c. So the question is that integral of 2x minus 1 divided by x minus 1 into, yes, x minus 1 into x plus 2 into x plus 3. That is equal to, the right hand side is, let me write the right hand side below here, a log mod x minus 1 plus b log mod x plus 2 plus c log, yes, x minus 3 plus k. Nothing, the question itself. Okay, so this is the left hand side, this is the right hand side. So the right hand side is a log x mod x minus 1 plus b log mod x minus 2 plus c log mod x minus 3 plus k. Okay, so hereafter we can consider the left hand side. So we are going to consider the left hand side. Okay, so that is, we are going to differentiate with respect to x. We are going to differentiate with respect to x. So we can write the left hand side 2x minus 1 divided by x minus 1 into x minus 2, yes, x minus 1 into x plus 2 into x minus 3. So that is, hereafter we can write it as, yes, a by x minus 1, yes, a by x minus 1 plus, okay, we are just considering the left hand side. So this is the left hand side, 2x minus 1 divided by x minus 1 into x plus 2 into x minus 3. So we can write as a divided by x minus 1 plus b divided by, yes, x plus 2 plus c divided by x minus 3. Okay, c divided by x minus 3. So hereafter, just consider this one, That is x minus 1 into, yes, x minus 1 into x plus 2 into x plus 2 into x minus 3. Okay, so just divide here, just multiply here. That is a by x minus 1 into this part. That is x minus 1 into x plus 2 into x minus 3. Okay, so we can write. I'm going to write the right hand side only. Okay, so after multiplying x minus 1 into x plus 2 into x minus 3, here we can write the right hand side. Yes, RHS. So for this one, the RHS a into x minus 1. Yes, that is the denominator into x minus 1 into x plus 2 into x minus 3. So we can cancel here. So a into x plus 2 into x minus 3 plus, yes, let me write here, RHS plus b into x plus 2. Again, we are going to multiply this for all term here. Okay, so that is x minus 1 into x plus 2 into x minus 3 into x minus 3. Okay, so look at here x plus 2 is in the numerator and x plus 2 in the denominator, so just cancel this. Okay, so similarly we can write c divided by x minus 3. Yes, c by x minus 3 into x minus 1 into x plus 2 into x minus 3. c by x minus 3 into the same term x minus 1 into, yes, x minus 1 into x plus 2 into x minus 3. After that we can cancel this. Okay, so in the next step simply we can write, that means RHS we can write it as a into x plus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x plus 2. Okay, so that will be the next steps. Because already x minus 1 cancelled here, x plus 2 is already cancelled here, and here x minus 3 is cancelled. And also from the question we can write the LHS. From the question the LHS is 2x minus 1. And after that we already multiplied the denominator on the LHS here. So the final step is a into, we can write a into x plus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x plus 2. So in the question they are asking us to find the value of a, b, c. So how we can find the value of a, b, c? Just look at here. This is the LHS. Okay, 2x minus 1, and here a into x plus 2 into, yes, a into x plus 2 into x minus 3 plus b into x minus 1 into x minus 3 plus c into x minus 1 into x plus 2. So hereafter, first of all, while we are going to substitute x is equal to I am going to substitute the value of x is equal to, yes, 1. So while I am substituting the value of x is equal to 1, the left hand side become 2 into, yes, 2 into 1. That is 2 into 1 means 2. Yes, 2 minus 1 is equal to, yes, just look at here. While we are substituting the value of x is equal to 1, yes, here it will become 1 minus 1. So the term b, it will cancel, and here c, 1 minus 1 again. So here b, the term b and c will cancel. Only we have a. So that means for x is equal to 1, 2 into, yes, 2 into 1, that is 2 minus 1. So 1 is equal to, yes, 1 plus 2. 1 plus 2 means 3. So 3 into 1 minus 3. 1 minus 3 means minus 2. So 3 into minus 2 means minus 6. So minus 6a. So hereafter we can write a is equal to minus 1 by 6. We can write the value of a is equal to minus 1 by 6. Similarly, just substitute the value of, okay, first of all, we just substitute the value of x is equal to 1. So while we are substituting the value of x is equal to 1, we got a is equal to minus 1 by 6. And after that, while we are going to substitute the value of x is equal to minus 2, just look at here. If you are going to substitute the value of x is equal to minus 2, just look at minus 2 plus 2. minus 2 plus 2 means 0. So the term a, it will cancel, it will become 0. And also here, just look at here, minus 2, yes. So here minus 2 plus 2. Minus 2 plus 2 means 0. Okay, so the term a and c, both of them become 0, only b is remaining. Okay, so when x is equal to minus 2, when x is equal to minus 2, yes, x is equal to minus 2, x plus 2, when x is equal to minus 2, x is equal to minus 2, we got b is equal to minus 1 by 3. Okay, and similarly, when x is equal to 3, x is equal to 3. When x is equal to 3, we got, just look at here, when x is equal to 3 means, yes, this term will become 0. That is a into x plus 2. So 3 plus 2 into 0. Plus here, you can see x minus 3. So when the value of x is equal to 3, this term a and b will become 0. Only the term, this term, 3 minus 1. 3 minus 1 means 2. Okay, 3 minus 1 is 2. And here 3 plus 2 means 5. So we can write the value of, yes, value of x is equal to 3. We got c is equal to 1 by 2. C is equal to 1 by 2. So simply we can write a is equal to minus 1 by 6 and b is equal to minus 1 by 3. Yes, a is equal to minus 1 by 6, b is equal to minus 1 by 3 and c is equal to 1 by 2. Yes, so this is the final answer. So, okay, for the third question, option B is the correct answer. So the fourth question is that. So the fourth question is integral of 0 to 1 root of 1 plus x divided by 1 minus x dx. So this is the next one. Okay, yes. So this is the next question. Integral of 0 to 1 root of 1 plus x divided by 1 minus x dx. So this is the next question. Okay, so we need to find the value of this one. So the first step is look at the denominator 1 minus x. So first of all we can write 0 to 1 root of 1 plus x divided by 1 minus x. Yes, 1 minus x into, we can take the conjugate, that is 1 plus x. Here just multiply both in numerator and denominator. The net effect is, that is 1 plus x. The net effect is 0. Okay, so that is 1 plus x into 1 plus x, that is in the numerator, and here in the denominator 1 minus x into 1 plus x. So hereafter for this one we can write it as for the numerator it will become integral 0 to 1 root of 1 plus x the whole square divided by 1 plus x the whole square divided by 1 minus x into 1 plus x. Okay, yes. So that means in the next step, yes. So let me write here. Yes, this one. Here you can see square 1 plus x the whole square and root. Okay, so for the numerator we can write 0 to 1. The numerator will become only 1 plus x divided by, yes, the numerator is 0 to 1 plus x dx. Yes, dx divided by, what about the denominator? Just look at here. Yes, dx is here and also here it is dx. And for the denominator we can write it as root of 1 minus x squared. So this will be the denominator. So the numerator is 0 to 1 plus x divided by root of 1 minus x squared dx. Yes. Okay, nothing. First of all, we just multiply the conjugate here on both numerator and denominator. So the numerator will become 1 plus x the whole square. So for this one, we can write as, yes, because here there is square root. Yes, here it is square 1 plus x the whole square, and here it is square root. So for the numerator we can write it as 1 plus x, and for the denominator 1 minus x into 1 plus x means root of 1 minus x square. Okay, so in the next step I am going to write this as integral of 0 to 1. Integral of 0 to 1, we can write 1 divided by, yes, we can split this 1 divided by root of 1 divided by root of 1 minus x square, 1 divided by root of 1 minus x square, plus integral of 0 to 1. 0 to 1, the next is x. So x divided by root of 1 minus x square dx. And also here, yes, 1 by 1 minus x square dx. Yes. Okay, so for this one, dx divided by root of 1 minus x square. So what is that? So that means sine inverse x, isn't it? So that is, we can write sine inverse, yes, sine inverse x. So the limit is 0 to, yes, 0 to 1. So that is the limit. Plus here x dx divided by root of 1 minus x square, root of 1 minus x square. So that is, we can write, yes, we can write the same 0 to 1, yes, 0 to 1, the upper limit x dx divided by root of, yes, root of 1 minus x square, root of 1 minus x square. So hereafter, on the next step, 1 minus x square, for 1 minus x square we can substitute it as t. Okay, so 1 minus x square, for we can substitute it as t. So that is minus 2x dx is equal to dt, isn't it? Minus 2x dx is equal to dt. Okay, so that is sine inverse x for the limit 0 to 1 plus, yes, 0 to 1 x dx. Okay, we already mentioned that 1 minus x square, 1 minus x square, we already mentioned here, 1 minus x square is equal to t. So that means root t. Here, while we are substituting this, it will become root t and x dx. Okay, so that means for x dx, that means, yes, for x dx, dt divided by minus 2. So that is, in the next step we can write, yes, integral of x dx. Yes. So 0 to 1 minus dt, So here we can see 1 by 2 outside. So we can take 1 by 2 outside. Yes, 1 by 2 into, yes, integral of dt divided by root t. Yes. So wait a second, there is a, yes, limit is going to change. So it will become 1 to 0, yes, 1 by 2 into 1 to 0 of integral minus dt, yes, minus dt divided by 2 root t. Okay, for the next one we can apply the value. So sine x is equal to 1, yes, sine inverse x. So that is 4 pi by 2 minus 0, yes, pi by 2 minus 0 plus here 0 to 1, sorry, the limit is 1 to 0 minus dt, yes, minus dt divided by 2 root t, minus dt divided by 2 root t. Okay, so in the next step it's easy, just apply the values here, just apply the values, just apply the limits. So for this one we can write it as pi by 2 plus minus dt divided by root t. Okay, for this one it is minus root t for the limit 1 to 0. So hereafter just apply the values, pi by 2 plus upper limit 0, lower limit is 1. So it become 0 plus 1. It will become 0 plus 1. So the answer is pi by 2 plus 1. Pi by 2 plus 1 is the answer. Okay, for this question, option A is the correct answer. So answer is pi by 2 plus 1.